Qualities. Last year when I did this lesson, I think I tried to fit it all into one day, and it was just kind of a long lesson, and so I decided to split it up into 2 days. So it's going to be 2 shorter lessons instead of one really long lesson. What?
It's Thursday.
Thursday.
I'm not going to remember anything on Monday.
Yeah. It'll give you a refresher for Monday. So today's lesson, not that long. And neither is Monday's lesson, but together it was like a lot.
So homework quiz on
So
Monday.
it's only
Yeah.
one day?
Mm-hmm. They're similar. They're similar. You are still going to have a homework quiz on Monday.
Say what?
I have extra credit in homework.
Huh?
What's happening?
Okay, I'll start over. So last year when I did solving rational inequalities, I tried to fit it all into one day and it was kind of long. So this year we're going to split it up into 2 days. So we're going to do the first part today, we're going to do the second part on Monday, and you are going to have homework quizzes over both parts though. So you'll have a homework quiz over the first part, which is solving rational inequalities that are going to have common denominators. And then on Monday, we're going to talk about how to solve them when they don't have common denominators, and you will have a homework quiz on Tuesday over no common denominators.
Okay.
All right, so that's kind of how I split it up. But it just makes both days like kind of easier and less, and you have a lot of time to do your homework in class and stuff like that. So it kind of makes things nice. All right. So when you're solving inequalities are the less than and the greater than signs. These guys right here. So your problems are going to look kind of something like that. So what we need to figure out is we need to figure out the intervals where your inequality is positive or negative. Because if you are less than 0, your answer is going to be the interval where you are negative. And if your inequality says greater than 0, your answer is going to be the interval where you're positive. So we're going to do these things. They're called sign charts. All right. So step 1, it says we're going to move everything to one side. We got to make it equal 0. All right, so step 1, you have to make it equal 0, just like when you're normally solving. And we are going to set the top and the bottom of the fraction equal to 0. These are going to be the instances where your rational function is going to switch from either positive to negative or negative to positive. And then we'll draw a number line, and we're going to use some test numbers to figure out what's going on in my intervals. And I know it might not make a lot of sense right now, but as we do examples, I think it will. Now, one of the important things here is that if your critical points, which are the numbers you get when you set your function equal to 0, if they are vertical asymptotes, they are not ever going to be included in your answer because vertical asymptotes always get parentheses. So vertical asymptotes are not included. Also, if your inequality does not have the or equal to line, those numbers are also not included because it is just greater than or less than. So they will only be included if it has that or equal to line and it is not a vertical asymptote. And that will make sense as I will do an example and I'll show you what I'm talking about. All right. So on example 32 here, we are just going to figure out where this where this rational function is 0, where it's positive, and where it's negative. All right, so to figure out where the zeros are, I'm going to set the top equal to 0. So when I set the top of my fraction equal to 0, I get x equals -3 and 5. So my function is going to equal 0 at -3 and 5. Now, what about the vertical asymptote? Where would that be at? Out on the bottom. So we're going to set the bottom equal to 0, and you get 1/2. So all of these numbers are my critical numbers. The zeros and the asymptotes. All right, so 1/2, -3, and 5 are all of my critical numbers where my graph could possibly change sign. And so I'm going to do a number line. And I'm going to put all of these critical numbers on my number line. So I'm going to start with -3. Then I'm going to go to 1/2. And then I'm going to go to 5. All right, so I've got these intervals now. All right, so I've got the interval from -infinity to -3, from -3 to 1/2, 1/2 to 5, and 5 to infinity. So I've got these intervals, and I got to figure out what's happening in these intervals. I got to figure out if I'm positive or if I'm negative. And those are going to be your two options. You shouldn't get anything else because all of the other things like the zeros and the undefines are your critical numbers that we found. So that's why we find these critical numbers, because that's where your function could change. All right, now to figure out what's going on in this interval, we're going to do a test number. So what is a good number on the left side of -3? Could be anything. Anything on the left side. -5. And if I were you, I would kind of write that number a little bit smaller, because it's not really going to matter a whole lot. But any number over here on the left side of -3, you could use -10 if you wanted to. But anything over here on the left side of -3 we can use. And we're going to plug it back into my original equation. All right, so we're going to plug it in back to this guy right here. Now, I don't care what the number is. All right, so you don't actually have to figure out the number. What I care about is the sign. I want to know if it's positive or negative. So, -5 plus 3 is negative. All right, -5 minus 5.
Negative.
And 2 times -5 minus 1.
Negative.
Negative. All right, so if I have 3 negatives, will that be a negative number or a positive number?
Negative.
A negative. So I know in this interval, that's going to be a negative number. Okay, so what's a good test number between -3 and 1/2?
1. Wait.
What's another one? 0. But you could use 1. No, you couldn't use 1. 1 would be on the other side. Yeah. 0. So once again, I don't care about whether what the number is. I care about whether it's negative or positive. So when I plug 0 plus 3 is?
Positive.
0 minus 5?
Positive.
0 minus 5?
Minus. Negative.
Negative. 2 times 0 minus 1?
Negative.
Negative. All right, so 2 negatives
Positive.
going to make a positive. All right, so between 1/2 and 5?
1.
Now I can use 1. All right, so 1 plus 3?
4. Positive.
Positive. And 1 minus 5?
Negative.
And 2 times 1 minus 1?
Positive.
Positive. So 1 negative is going to be?
Negative.
And then what's a good test number on the right side of 5? 6. All right, so 6 plus 3?
Positive.
Positive. 6 minus 5?
Positive.
And 2 times 6 minus 1?
Positive.
Positive. So all positives, it's going to be
Positive.
positive. All right, so a lot of times you are going to see an alternating pattern, but it doesn't always happen, so you do need to make sure you go and check. Okay, so if this question was asking me for when I was greater than 0. All right, so if I had the question where it was positive, which means that your guy is greater than 0, I'm going to put the intervals where I'm positive. So from -3 to 1/2, and then from
Union 5 to infinity.
5 to infinity. Yep. So -3 to 1/2, and then 5 to infinity. And if I wanted the intervals where you are negative,
Negative infinity. -3.
negative infinity to -3, and
Union 1/2 to 5.
1/2 to 5. All right, so one of the common mistakes I see is people will use their test numbers as their answer, which is why I say to make them kind of tiny so you don't use them, or highlight your critical points, because these numbers here are going to be the numbers that are in your answer for your intervals. Does that kind of make sense? Okay, I meant to make 36 another one where it just equals f of x. So ignore this less than 0 for right now. Okay, so I'm going to do the same thing. I'm going to figure out where I'm 0, where I'm positive, and where I'm negative. Okay, so I got to come up with my critical points. And so I'm going to factor. And the top factors out to be x plus 1 and x minus 1. And the bottom just stays x. The zeros are going to come from the top. So, yep, the zeros are going to be x equals positive 1 and negative 1. Where would I have a vertical asymptote at? at 0, which I still need to write down because it's going to be a number, a critical number on my number line, but it is an asymptote, not technically a 0. Okay, so on my number line, I'm going to put -1, 0, and 1. All right, and I'm going to go back and I'm going to take some test numbers and I'm going to plug them back in. You can plug them back into the very original or into the factored version. I normally like doing the factored version because I think it's easier to think about what the signs would be in your head.
-2.
Sorry, yes, -2 is a good test number. So, -2 plus 1.
Negative.
-2 minus 1.
Negative.
And -2 on the bottom is going to be negative. So 3 negatives is going to be a
Negative.
negative. All right, what's a good number between 0 and -1?
1. Sorry. Half.
A half, yeah. You have to use a decimal or a fraction here, but remember, we don't actually care about the number. So even if you have to do a weird number like a fraction, I just care about positive or negative. So -1/2 plus 1,
Positive.
-1/2 minus 1,
Negative.
and then -1/2 on the bottom is going to be negative.
Positive.
So the interval would be positive because you'd have 2 negatives.
0.5.
And then between 0 and 5 would be positive 0.5. So the 0.5 plus 1, positive. 0.5 minus 1,
Negative.
and then positive 0.5 on the bottom.
Negative.
So negative number. And then what do you think the last one's going to be?
2. It's probably positive.
Positive, yep. So when you plug 2 in, positive, 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 which gives you positive. So this work right here, like where I'm doing my little minus and the pluses, I don't need to see that. If you can do it in your head, that's fine. But if you start losing your negatives, it might help you to kind of write them down like I'm doing. So I also don't need to see the test number. If you want to do that in your head, that's also fine. But remember, it doesn't always alternate. I will say like 80% of the time it does, but then you'll come across a question where it doesn't. So just kind of watch out for that. All right, so when you're doing your intervals, we're using the critical points. So -1, 0, and 1, not the test numbers. Where would I be positive?
-1 to 0, union 1 to infinity.
Perfect. And where would I be negative? Mm-hmm. 0 to 1. Sweet. Okay, does that make sense so far?
Yes, ma'am.
All right, I've got 2 more examples on the back where it actually is like an inequality. And I'm going to talk about some of the homework ones. So this is going to be what you're going to see on your homework and on your test. Is they're going to give you a rational function, and it's going to say less than or greater than 0. So the less than 0 means that I'm looking for the negative interval. So all this less than 0 here means is that when you're doing your number line, the answer is the negative interval. So I want to know when my rational is going to be negative. But we still got to do the whole process. We got to figure out our critical numbers by setting the top equal to 0 and the bottom equal to 0. All right, so when I set the top equal to 0, I get 3. And when I set the bottom equal to 0, I get -2. So I'm going to put -2 on my number line and 3 on my number line.
No VA.
There is the -2 is your VA. Now, it is a VA, but because my inequality doesn't have the or equal to line, everything gets a parentheses. Does that make sense? Because there's no or equal to line underneath this less than sign. So everything's going to get a parentheses, even the 3. All right, so now I got to figure out my intervals. So what's a good number on the left side of -2? -3. So -3 minus 3 is?
0, which is positive.
Negative. -3 minus 3 is -6.
Oh.
Because they're both the same sign. Mm-hmm. So negative, and then -3 plus 2 is? Negative. So double negative makes a?
Positive.
Positive. What's a good number between -2 and 3?
0.
0. And then 0 minus 3 is?
Negative.
And 0 plus 2 is?
Positive.
And negative divided by a positive?
Negative.
Okay, and then what's a good number on the right side of 3?
4.
4,
Both positive.
both positive. Yep. All right, so I have my number line, so now I just need to write the answer. So I'm looking for the spot that's negative, and like I said, everything's a parentheses because it doesn't have the or equal to line. So what would my answer be?
-2, 3.
Yep, -2, 3. All right, let's go down to 38. All right, on 38, it is less than or equal to 0. So do I want the negative or the positive?
Negative.
Negative again. Because it's less than. All right, everything is already factored for me, so I can go ahead and find... my critical points. So I'm going to set the top equal to 0 and the bottom equal to 0, which is going to give me x equals
3.5.
3.5 or 7/2, which I'm good with a fraction or a decimal. And 5. All right, so 3.5 and 5 on my number line. So those are my critical numbers. Which one is an asymptote? The 5. The 5 is your vertical asymptote, which this one it is going to matter, and we'll talk about that in a second. But let's figure out my intervals. So what's a good number on the left side of 3? 0. So when I plug 0 in, 0 minus 7 is negative, and 0 minus 5 is negative. So double negative is going to make a positive. What's a good number between 3.5 and 5? 4. All right, so 2 times 4 is 8 minus 7 would give you a positive. And then 4 minus 5 on the bottom would give you a negative. So a positive divided by a negative is going to be negative. All right, and then what's a good number on the right side of 5? 6. All right, so that's going to be positive. So it'll be positive. All right, now on this one, my interval is going to be from what to what?
3.5 to 5.
Yes, very good. Okay, so bracket 3.5, comma 5 gets a parentheses. So 3.5 is going to get a bracket because of the or equal to line right here. But 5 has to have a parentheses because it's an asymptote, and asymptotes always get parentheses, are never included. But the 3.5 is a 0, which you can include as 0 because it would actually equal 0. Does that make sense? Okay, today's lesson okay? All right, so look at the homework. All right, remember your first step is you do have to get everything to one side first and make your fraction equal 0. On number 4, it's 2 separate fractions, which we haven't really talked about, but what do you notice about these fractions? They have the same denominator, so if you want to add them up, we can, and so we can add these up and make it 8 over x minus 2.
And when there's a number in the numerator, that doesn't do anything.
Right, and so that 8's not going to really do anything. It's always positive. It's not going to give you any critical points because there's no x with it. So this number line would only have 2 on your number line. All right, the other one I wanted to kind of talk about was number 2. So on number 2, it doesn't equal 0, or it's not greater than 0 yet. What would you have to do first? Yeah, and when you subtract this 3 over, yes, and so it kind of works out nicely for us. And we are set up to go to make my number line. I think that's it. I think the rest of them are good. Some of them you do have to factor, and so you get some more intervals and some more number lines, but it kind of works out that same way. All right, questions, comments, concerns?
Nope.
Sweet. Rest of the time you have to work on this. Remember, you do have a homework quiz over it on Monday, and then Monday we'll do the no common denominators, and that'll be the last lesson. Oh, and then I was telling second period, because I know we're almost there, done with the second semester, or first semester. Unit 6, you're going to have that test before Thanksgiving break. And then when we get back from Thanksgiving break, we're going to start Unit 7 to kind of make things a little easier for y'all where we're not testing Unit 7 and then also turning around and doing the midterm. We're just going to take our time with Unit 7, and the Unit 7 test will be the midterm.
Okay.
Does that make sense? Because otherwise, I think we're going to test, and then like a day later, you're going to have the midterm, which isn't a whole lot of time to prepare for it. And it's just a lot of testing. So Ms. Paxton and I talked, and I think we're just going to give the Unit 7 test as your midterm. So just make sure, the only downside is you're not going to be able to do test correction, so just make sure you study for that midterm and you are really prepared for it.
Is Unit 7 hard?
No, it's logs and exponentials. Do you remember doing logs last year? You did the murder mystery with the logs, I think, right?
Yeah.
Mm-hmm. So with the log base thing and the expo, so that's what it's over. So it's not a hard unit. I think if anything, it's just because it's at the end of the semester and everybody's ready for break. Why can't I?